Hey students, how are you? Mr. Halpern again. We are here for another video. We're going to be talking today about something called percent composition. Percent composition, what is it, you might ask? Percent composition is the percentage of a mass or biomass of each material found in a particular item. Okay, so we might think of a coin as an example. All right, so a coin has both copper and zinc if it's post 1982, and we want to sometimes figure out how much copper and how much zinc there is in there. Well, one handy way of doing that is by using the masses and figuring out a percentage of the total that is those individual elements in there. So we have an example here to help teach you a little bit about how to calculate percent composition. So remember, we're using the masses. So a post 1982 penny with a mass of 2.5 grams, right, is composed of 2.4375 grams of zinc and 0.0625 grams of copper. Okay, so what is the percentage composition, right? How much zinc and how much copper do we actually have in this penny? So we're going to figure this out. So the first thing to do is you're going to take the zinc and you're going to divide it by the total. Now what's the total? The total is 2.500 grams. What's the zinc? 2.4375. So you're going to take those two numbers and you're going to divide them, and you'd get a percentage on your calculator. You would you press that in, and you get actually you get a decimal. My fault. You wouldn't get a percentage. You get a decimal. To get a percentage after that, you'd have to multiply it by 100. And what do you get? You get, oh, let's do this. You get 97.5% zinc. How do we do that? Again, we took the mass of zinc, divided it by the total mass of the item we're talking about, multiplied it by 100. So, are we done? No. We haven't figured out yet what copper is, the percentage of copper. You might guess by looking at 97.5% how much copper is in there. But let's figure it out mathematically. So, what we do again is we take the mass of the copper in there, which is 0.0625 grams, divide it by 2.5, which is the total, multiply it by 100, and we get 2.5% copper. So that means that that particular penny, 2.5% of the mass of that penny is copper. The rest of it, 97.5, is zinc. Okay, so we're going to take this idea and move away from a penny. Okay, we're going to think of bigger problems, right? Bigger questions, like if you were, again, a miner or a refiner and you had a company, why would you choose to pick one metal ore over another, right? Some metal ores have more of a particular metal than others. Also, you might have a percentage or a part of that metal ore, right? And that might be larger or smaller than the percentage of another metal ore, a different kind of metal ore. And to show you, we have 3 different metal ores that you see on your notes there. All right, these are copper metal ores. These all have copper. We have chalcocite, which is that rock there. We have, on the top, we have chalcopyrite, and then we have malachite. All of these are copper containing. However, their formulas are slightly different from each other. Okay, the formulas are below. I'll move my little screen there. Formulas are below, and we're going to take these formulas and use these masses, the molar masses of these, to figure out what the percent composition would be. So let's start with the percent composition of copper in chalcocite. Chalcocite is Cu2 sulfide, sulfur. So we have 2 coppers and 1 sulfur. So how do we figure out the molar mass of copper then in there? Well, first off, we have to figure out what is the mass of copper, the molar mass of copper. Okay? The molar mass of copper, we look at the periodic table and we see that it is 63.55 grams. However, we have 2 copper here. So when you multiply 63.55 times 2, you get 127.1. Okay? Now, when you get 127.1 grams of copper, what do we do from there? Well, we have to again divide by the total mass. So how do we figure out the total mass of chalcocite? Well, we now have to add copper, the 2 coppers, and the sulfur there. If you add those masses, you get 159.17 grams. So we take those 2 numbers, divide them, multiply by 100, and get 79.85% copper out of the total chalcocite. So the formula for chalcocite is used along with the molar mass to figure out the percentage of each individual element. So if we were to do sulfur, what we'd have to do is the same thing. We'd figure out what is the molar mass of sulfur, divide it by the total mass of chalcocite, and multiply it by 100. We should get 20.15% sulfur. Now, if we were really a miner, right, or a refiner of metals, okay, and we were put in charge of making a decision either to mine chalcocite or to mine chalcopyrite, this might be a classic question you could see. So suppose you had the choice of either mining 20% chalcocite, that means that of the ground that you are digging up, 20% of it is chalcocite, okay? Or if you had 30% chalcopyrite, that means 30% of the ground is this chalcopyrite. Which one would you choose to dig up, to mine? Okay? Well, what this is asking you is really how much copper is there to mine in these different options. The more copper will give you the more profit. So what we first have to figure out is that if we use, let's as an example, 100 grams, right? 20% of 100 grams of ground would supposedly be this chalcocite, right? That would be about 20 grams of chalcocite. We use 100 grams for simplicity, just to keep the numbers nice and easy to calculate in the beginning. So we have 20 grams of copper sulfide or chalcocite. Now what do we do from here? Again, what we do from here is we take the copper, right, and we divide it by the total mass of chalcocite. And then what we do is we have to figure out, okay, so that's the proportion there. How much copper would we have in only 20 grams of chalcocite? So we create a proportion, we cross multiply, and we get 15.97 grams of copper. Okay? So once we've figured that out, we have to figure out now chalcopyrite. Chalcopyrite is 30%, so we have 30% of our rock is chalcopyrite. So that means out of 100 grams, that'd be 30 grams of chalcopyrite. Okay, so copper in chalcopyrite's formula, there's only one of them. So the mass would be 63.55 grams of copper. When we take it and divide it by the total, then we're starting to get the percent composition. So once we get the percent composition, we have to create a proportion because we don't have 183.54 grams of this chalcopyrite. We don't have a full mole. What we have is only 30 grams. So out of 30 grams, how much is copper? Create a proportion, cross multiply, and you will get 10.39 grams. So which one would you choose? Would you choose chalcocite or chalcopyrite? If you look at the numbers, you'll see that chalcocite has more copper in it if it's 20%. So that's significant. Even though it had a smaller percentage within the ore that you had, right? The mineral was only 20% of the overall ore that you had, the overall rock that you had. Okay? Even though that was the case, it still had more copper. So that's a significant calculation that someone would need to do if they were mining for copper in this area. So therefore, to sum it up, we would say an ore of 20% chalcocite contains more copper per 100 grams than an ore of 30% chalcopyrite and would be a better choice. I hope you learned a little bit about percent compositions and how we might use them to determine whether or not to mine for specific ores and minerals. Thank you.